Can you do the calculator too, so that way
Okay.
we know how to do it?
So I want this thing to 3 significant digits. And that sort of looks like 40 to the third, right? Sort of looks like that. So it looks like 64 with 3 of those things on it. So yeah, I'd expect something around 6.4 times 10 to the fourth is what I'm looking for. Or something maybe a little bit bigger than that. And, So I'm guessing. I'm guessing the answer is delta is what I'm thinking. All right, so I'll take my calculator and I'll put 39.7, hit the X to the box key, hit the pi button, hit enter, and then see what it says. 39.7 raised to the pi. Well, it doesn't work because it's not on, but other than that, it would work. 39.7 raised to the pi. 1.05 times 10 to the fifth. So delta was correct. Your $3,000 calculator didn't get delta?
I'm pissed off with this thing. I'm about to throw it away.
Oh, you mean I got? All right, Control Alt. All right, we're thinking about going to number 2. Seeing that. What? What did I do? I don't know how we did it. Okay, so now we're looking at this one. We're looking for the horizontal component. So that's V in the X direction. We know it's 3971 cosine 142.5. All right, now we know that this is a second quadrant answer. So it can't be C, it can't be A. So we only have 2 possibilities that it could be. Okay, so now do we want to put it on a calculator or do we want to guess? We're going to guess? All right. Well, if we guess, we find that the first quadrant reference angle here is going to be like 30-something.
Minus 3150.
30, going to be 37.5, right? So that's going to be a pretty big number because we have to get all the way up to 60 before it's a half. So I would go with D. And then I'd put it in my calculator just to make sure. 3971 times cosine 142.5. But at least don't, whatever you do, yeah, that's the right answer. So whatever you do, don't guess the positive answers because it's a second quadrant vector and it can't be.
But I'm guessing on the actual test up to the opposite.
Huh? You're thinking about that. All right, so next we want to go radians to degrees. Okay, and again, we know that pi radians is 180. This is bigger than pi because pi is 3.12, what is it, 141592, whatever it is. So that means it's not that guy, it's not this guy, and it can't be that guy. So the only answer it can be is this guy. Okay, so now we have to go and see whether or not that's the case. All right, so 4.752 is to some degrees as pi is to 180. Okay, so we're going to go 180 times 4.752 divided by pi. That's what we're going to put in our calculator. But we already know the right answer, so we don't really have to do that. We're just doing it just to appease the audience. 180 times 4.752 divided by pi. Oh, look at that, 272 degrees. 3 D's in a row. Now, what's the chances of the test going to have 3 D's in a row? 1, 2, and 3.
None.
None. Zero's apple. So don't
You
we?
gotta look like this.
So don't even try to memorize that. All right. Now oh, look at that. Got all hosed here. Now this might be a little more difficult to guess at. Okay, I'm going to guess D. Now, the reason I'm guessing D is because I'm thinking that there's 2 answers to this question. And that's the only guy with two solutions, so that's why I'm guessing D. All right, so now we got to do the math and find out. So if I add logs, that's the same as multiplying. So this is log of 3x plus 8 times x minus 5 is equal to 1.86. So I've got log of 3x squared minus 7x minus 40 is equal to 1.86. And then I'm going to raise this as powers of e. And I'm going to say 3x squared minus 7x minus 40 is equal to some number. So I'll go e raised to the 1.86. And I'm going to get a 6.4237. All right, so I'm going to bring that on the other side of the equation. 3x squared minus 7x minus. Okay, so I'm going to subtract 40 from my answer. 33.5763 is equal to 0. So now I can factor this. Anybody think we ought to factor it? No? So we're not going to do that. All right. Not going to factor. We can use the quadratic formula. Anybody want to use the quadratic formula? X is equal to 7 plus or minus the square root of 7 squared minus 4 times 3 times minus 33.5763 divided by 2a, 2 times 3. Or we could just put the stupid thing in our calculator and write down the answer. So I'm going to go second function, polynomial solver, hit the 1 key, put in an a of 3, and put in a b of minus 7, and put in a c of minus 33.5763, and then just tell it to solve it. And then I'll just put down that the answer is x1 is minus 2.37638, and then x2 is 4.709717769. And then I say, well, I don't have that many significant digits, but it looks like D is not correct.
No.
So D is not correct, and none of them are correct. And the right answer is that. But it can't be that because we only have 3 significant digits. So final answer in green. Final answer x1 is equal to minus 2.38, and x2 is equal to 4.71. All right. Yes?
Will this occur on the test, or will they all be somewhat?
Yes, the study guide came right off the exam bank, so it's entirely possible that a random selection off the exam bank may include this guy.
So in that case, we just do what you did there?
Yeah.
Okay.
Can you go back so I can write
Well,
all the steps?
I would probably go and if I didn't have a calculator with a solve the quadratic solver on the calculator, then I would have used the quadratic formula. I would have used that guy to solve it.
I can
Yeah.
do that.
Okay.
So, but yeah, I try to factor it first,
Thanks.
and then I'd use the quadratic formula second, and then I remember my calculator does it for me automatically, so I just put it in there and put it down. And yes, I have been using the same exam bank for probably 8 years now, and right answers have been removed in the past, and they still are. So the key is something that I make while you guys are taking the quiz, taking the test. So I make up the... Yeah, but it's entirely possible that the test will have a multiple choice question on it with no answer.
Okay.
And because I don't look at the test is something I make up on Friday. So I haven't looked at it yet. But I could remove an answer on purpose. But that's okay, because there's a nice curve that I apply. So life will be all right. The other thing we could do is put these answers in there one at a time and see if they work. And they probably don't. Yeah, we already tried that. Didn't work. Yeah. And if I don't take out the right answer, the keys are made by some graduate student that probably did. Some graduate student that probably can't do math. Okay, so we're gonna do the same exact thing over again. I have 2x squared minus x minus 21. So the first thing I'm going to do is ask myself if I can factor it, and clearly I can. Minus 7 plus 3. So because I can factor it, I'm not even going to put it in my calculator to see what the right answer is. So x solution set minus 3 and 7 over 2. But I could have, if I decided not to do that, I could have gone to my polynomial solver again. And I could have put in a 2 and a minus 1 and a minus 21 and then said solve, and I would have got a minus 3 and a 7 over 2.
Ooh, look at that.
But
I can
that
get one
took me longer than it took me to factor the stupid thing. So that's why I would look to factor it first before I would go on to something else. And notice that this is not multiple choice, so you don't have the option of picking the wrong answer. It is extremely embarrassing if you have 4 multiple choice questions and you miss them all because you picked the wrong one, right?
Mr.
Yeah.
I hate to keep asking these.
No, they're not dumbass questions. They're only asked by the front row.
Would you rather have them in fraction or in decimal form?
Doesn't matter.
Doesn't matter. Okay.
Yeah. This is a Tech Math 3 pre-calculus class combined. So depending on what mode your calculator's in, would give you, I could have done quadratic formula on that, right? And I could have ended up with something other than a fraction. So whatever your calculator tells you, it's 1 point, let's see, what would it be, 3 point something? 3.5. So there's nothing wrong with 3.5. There's nothing wrong with 3.5. You know. Now there's something wrong with 3.50000 with a line there. There'd be something wrong with that because
if we do get like reference like a really weird decimal 26 times, like even like 2
Did it tell you? The problem didn't say. It just said solve.
Yeah.
So normally, if in fact that's going to matter, it's going to say give me 3 significant digits or give me 4 significant digits. So unless you go way off on the far end of something and give me all 10 digits in your calculator when you know you shouldn't, you know. Now you could put all 10 of them down and then write on the test, I don't know any better than to do this. And then I'd take that under consideration before I took full credit off for being whatever, you know. All right. Does that answer that question?
Yeah, thank you.
Yeah. But no, I don't have any preferred or right answer, right way to write something. Now notice that this one says use the quadratic formula. Do I really care if you actually do that? Well, probably not. But so what I would do, first thing I'd do is I'd try to factor it. 2x, x. So I could go plus 9 plus 2, right? And that's, so I can factor this. So I know the answer is going to be minus 2 and minus 9 over 2. So but it did say use quadratic formula, so I will do that too. But I wouldn't. And on the real test, however you get the answer is fine with me. So using quadratic formula, minus 13 plus or minus square root of 13 squared minus 4 times a times c divided by 2a. Okay, minus 13 plus or minus 6 ones. Oh, bummer, get out of there. Quit. All right, thank you very much. 169 minus 8 times 18. Oh, that's square root of 25 over 2. So I got minus 13 plus or minus 5 over 2. Wow. How can I be that hosed?
Oh my gosh.
That is really bad.
I don't judge.
What did I do wrong? That's 18. 9 plus 4 is 13. Minus 2 minus 9 over 2. Wow. Minus 13 plus, oh, 2a. Right, 2a. All right, that's better. So this is divided by 4. Divided by 4. That's much better. So I've got minus 18 divided by 4. And I've got minus 8 divided by 4, which becomes minus 2 and minus 9 over 2. So I end up with the same answer doing it that way. But I could have just as easily just put it in my calculator and said polynomial solver 2, 13, 18, solve. Oh, minus 2 and minus 9 over 2. Wow. I don't believe it. How did I? So even though it says to do it a particular way, each of our minds is wired differently. Mine is wired considerably differently than the first row. But in the second row and third row, I was closer to you guys probably. And Alex is looking at me. Like the fourth row probably isn't wired at all. So anyway, we have those days. Oh, now we come with a question that I only wrote it down 3 times. Negative 2 minus 9 over 2. Really?
Not good.
What do you mean you're not good?
I got minus 4.5 or minus 2. But it's okay.
Minus 4.5 is minus 9 over 2. That's the same answer.
Okay. Gotcha.
Somebody got some aspirin out there. Needs something. Anyway. So, what do you think? X to the minus 2. Good?
Yeah.
I like that one.
You like that one? Minus 1. No, your 9th grade teacher doesn't like that one. 1 over x squared. Your 9th grade teacher wants you to have positive exponents, right? So going back to 9th grade algebra, your exponents have to be positive. X to the minus 2 is wrong. So I'll probably only take 0.1 off just to be a pain in the rear end.
X2. 7 minus
All right.
2.
So even though it looks really simple, remember your 9th grade algebra spelling rules. There's a right way to spell and there's a wrong way to spell.
That one is intriguing.
Number 8. It has been determined that a particular bacteria grows 12% per day. How long will a culture, how large will it be in 12 days? Okay, so that'd be this plus 12% of that plus, plus, this has an answer. Plus, then it's going to have to be answer plus 12% of the answer. And then I'm going to have answer 2, answer 1. And then it's going to be answer 1 plus 12% of answer 1, which is going to be answer 2. And then I'm going to have answer 2 plus 12% of answer 2 is going to be answer 3. So it's going to be more confusing when I tell you how to get the right answer. Answer 3 plus 12% of answer 3, and that's going to give you your final answer. All right.
Or you can
Or you can do it the way the book wants you to do it, which says the population at times t is population naught e to the rt. Right? So P at 5 days is population naught. What's population naught? 1,400? I forgot already. 1,400 e to the 0.12 times 5. Yeah, 0.12 times 5. And then I could put in my calculator 1,400, if I had control of my calculator, 1,400 times E raised to, is that 0.6? 0.6. Boom. And I get an answer of 2,551. What? How many? What is it? Bacteria. Bacteria.
Sounds like salt.
Hello. Now we're going to 9.
Oh, the roof minus 180, right? Isn't it? What's the reference angle? It's 180 minus 185.
Okay, so we have a second quadrant answer. In the second quadrant, the angle of the second quadrant is 180 minus the reference angle. So I want to know the reference angle. So the reference angle rearranging is going to be 180 minus the angle in the second quadrant. So 180 minus 125 looks to be 55. 55 degrees. Okay, back to what Raimundo was talking about. The reference angle in the third quadrant is 180. The angle in the third quadrant is 180 plus the reference angle. And the angle in the fourth quadrant is 360 minus the reference angle. And we could rewrite all of those in pi. So in the second quadrant, I'm pi minus the reference angle. And in the third quadrant, I'm pi plus the reference angle. And in the fourth quadrant, I'm 2 pi minus the reference angle, if in fact we're doing this in radians. Okay, so we could be doing it in radians, we could be doing it in something else. Okay, number 10.
Physics again.
Find the sum. All right, so what I would do is I would find the xy components, add them together, and that would probably be what I would do. So I would go 4.0 cosine 18, 4 sine 18, 66, just 6, cosine 71, 6 sine 71. So I just put those guys in my calculator. 4, no I wouldn't, 4 times cosine 18, 3.8. And I wanted to change colors. 4 times sine 18, 1.24. 6 times cosine 71, 1.95. 1.95. 6 times sine 71, 5.67. I'm putting in my calculator and hitting the return key. Are you in radians again? Okay, I'm going to add them. So I'm they want me to use parallelogram methods to do it. Okay, we'll do that after I do this. I'll do it the other two ways first, and then I'll do that second. All right, so we'll, I add this. That's 4, that's 5. 5.85. Right? No, 9.5? 5.85? 7.5? 5.75. 6.8991. All right. So then my magnitude of the resultant, square root of 5.75 squared plus 6.91 squared. Um, 8.99. My angle is going to be a first quadrant answer, so I just take the arctangent of the y component divided by the x component. And it looks like I'm at, well, if I use the arctangent function, I might get a better answer. 50 degrees. The other thing I would do is I would just use my calculator to add them. So I would go and say 4, second function complex angle 18 plus 6, second function complex angle 71, and just hit the return key. And if I did that in my calculator would give me an answer of 8.99 angle 50 degrees. So I could do that too. I could just have my calculator do it. Now, the problem says to do it using parallelogram methods. All right, so what it's saying is that I got some guy, I'm going that way. Okay, and that guy is 18 degrees at 4. And then I have another guy over here going that way, and he's at 71 degrees and 6. And what I want to do is I want to know what this guy here is. Well, if I knew that angle, I could just use the law of cosines. So I drop a construction line there. I have 90 degrees on this side. I have 18 there, which means I have 80, 90, 72. 72 here. So that means the remainder, 360 minus 72 minus 90 minus 71 is 127. So this side, we'll call it C. So C is equal to square root of 4 squared plus 6 squared minus 2 times 4 times 6 times cosine 127. And then when I get that number, I will find out that number is, what am I going to find out? 8.99 when I put that in my calculator. Now I got to figure out what is the angle. So if this is 8.99, then I'd use the law of cosines and get this angle here. Can I get that angle there, A? Yeah, so I could say 8.99 divided by sine 127 is equal to 6 sine A. And then I could say A is the arcsine of what? Arcsine of 6 sine 127 divided by 8.99. And when I got that, I'd find out that I had 50 degrees, right? No, I don't have 50 degrees. What do I have? Arc sine 6 times sine 127 divided by 8.99, 32 degrees. And then I take that 32 plus that 18, and I'd say that this angle here is 50, which is the same answer that I already got 2 other times. So I end up with 0.99 angle 50, no matter how I do it. Okay. So if I were working when I work the problem on the key, what I would do is exactly what the problem asks, so I can see your work if somebody should do it that way. But I would also put it in my calculator to make sure I had the right answer. I wouldn't go and mess around doing it some way differently.
What was the final answer, Doug?
For the third time,
Yes, please.
0.899 angle 50. Or are you asking what the key actually says?
Yeah.
9.0 angle 50.2. So the key decided that I only have 2 significant digits. So 50, not 50, 9.0. 9.0 angle 50.2 is what the key thinks the answer is. I'd have to go back. Well, there's only 2 significant digits, so clearly I can't have 8.99, right? So 0.9 would be correct. And I never looked what the fractional degree was. I just wrote down 50 and didn't round it up or anything. Okay, now we're looking at number 11. No, we're not looking at 11 that way. We're looking at 11 this way. All right, so number 11. Where to go? All right, using vectors using trigonometry. All right, well that's no different. I would just put this in my calculator too. 37 second function complex angle 105 plus 43 second function angle complex angle 215, and tell me my answer is 46.1 angle 166.1, and I'd probably leave it at that. Now if I had to do it differently, I would go and okay, so there's my first guy sitting there at 105 degrees and 37, and then the second guy is sitting there, and that's 215, and this is 43 feet. And then I'd go and I'd calculate other angles. I would do other things until I
That's 46.1.
yeah. So the first thing I would do is find this angle, and then once I found that angle, I'd use the law of cosines. So I'd put a construction line this way, and then I'd say, well, this transversal going like that, this angle has to be the same as what? As that angle. Okay, so this that'd be 105. This guy's 15, I could get what was over on this side, and I could get that guy figured out. So I could do it if I wanted to. Okay, good enough? But again, I would go vector problems in your calculator, calculate the right answer, let it be. Unless, of course, you have a $300 calculator like somebody does in the front row that can't make it do squat, then that would be different. You got it? Got it? Oh, it's only $150?
Right here.
He's counting both of those. With the reason.
Okay. So what are we going to do about this? Well, we could say that this is 3 divided by 2 to the 5th, right? And then we could say that this is 1 over 2 squared, square root of 3 over 2. And we could say that that's the square root of 6 over 2, square root of 6 over 32. So we could do that maybe. Over 8?
6 over 8.
6 over 8. But we probably wouldn't. What we'd probably do is just put it in our calculator and say the square root of 3 over, 3 over 2,
306.
square root of 3 divided by 32. 0.306?
Yes, sir.
0.306.
My calculator approved the message.
Now, that's probably too many significant digits, so probably, 0.3 is probably a better answer. The key likes my square root of 6 over 8, but beauty's in the eye of the beholder. So the key likes that guy. There's nothing wrong with that guy. I probably would hold my nose and mark that one right and not care about it. It would depend on if you missed something before. If you haven't missed anything, and I got to that one, then this would be at least minus 0.1 significant digits. But let's say that I won't use anybody. Let's say John already missed 5 of the first 10, and I got down to there. I'd probably skip that he got something wrong there, right? Because he already got enough already. Yeah. Oh, the second row has articulated one of the Cordoville grading rules. Okay, so it needs to be re-articulated so the whole class knows it. And the rule says if for some reason you get a natural 100 on a test. Okay, show of hands. How many are going to do that on this test here? Yeah. Right, so those that get a natural one, now there's going to be extra points on the test, right?
Yes.
There's going to be some extra credit points. So you could get a 102 because of extra credit. That doesn't count if you miss something, right? Anybody know the extra credit question?
Something about it's going to be on the panel tomorrow.
That's right. So tomorrow there's a legislative forum we're going to, and there'll be a question about that legislative forum because everybody's supposed to be at it. Okay, so a couple years ago, the question was how many females were there on the forum,
Last year.
and the answer was none. There weren't any females there. Whatever the answer is, there was a female. Whatever the answer was, but if you're there, you'll know the answer.
Hey, this time we're going to count the podium.
So it could be something as simple as did a male or female sing the national anthem before the event?
Right.
Yeah. And if
What time is that?
Huh?
9 o'clock.
9 o'clock. Yeah, everybody's in the gym at 9 o'clock. But if for some weird reason you get 100 on the test, okay, this is going to apply to no one in the room. But if it happened, then on the next chapter test, your grade is 100. You still have to take the test, but what goes in the grade book is 100. Okay, so you could get a 37 on that test, 73 or whatever. Doesn't matter. 100 goes in the grade book. Okay, so that's one of those Cordoville grading rules.
And then what about the next one?
Your host.
Well, the next one doesn't count because you didn't get a natural 100 because you got a 73. Well, then it carry on to the next one. Yeah.
Then you're too smart for those classes. Just get it.
That's right. Then you shouldn't have been. First of all, if you get 100 on the first chapter test, There's no reason you should have been here in the first place. Should have been calculus 1, right?
If Ray gets 100 on the first one, we better get
Yeah.
100 on all.
All right, so back to what we're doing. Anyway, that was the articulation from the second row about some issue. Yeah, okay, so this is number 13. All right, so here's 13. So we look at this and we say, okay, well, I have x's and I have y's. If my x is 1/5, what is my y going to be? If my x is 1/5, then my y is going to be 1, right? Because the log base b of b is 1. Okay, so I look at these guys and say, okay, which one has y being a 1? Okay, not this guy, he doesn't go through 1. Not that guy, he doesn't go through 1. These two guys both go through 1. Now, why are they going through 1 at a funny place? Now, the normal log function looks like that. That's what the normal log function is. But this is a log with a fractional base. Okay? Now, can y ever be 0? Ever be negative? The log of base something, can y ever be 0? Okay, so y can't be 0, so it can't be this guy, can't be that guy. And coming over here, these guys don't work either because they go to 0. Okay, so it's either this guy or that guy. All right, so now we're going to pick a y that's a 2. If y were a 2, then what must x be? Then the log base 1/5 has to be 1/5 squared. Okay, so if y is a 2, then this has to be 1/25. Okay, any of these guys have that? Y is a 2. Y is a 2. None of these work. So I would say they're all wrong. Yeah. Well, maybe not. Let's look at this guy. When I cross through 1, when y is 2, 1/25. Yeah, okay. What if y were -2? Y were -2. -2 would be log base 1/5 of 1/5 to the -2, which would be 25. So at -2, when y was -2, I should be at 25, and so it looks like C. C, yeah. C was right, yep. Looking to the key, the key says C. What a bummer. What a loser author, anyway. Can't even come up with a more imaginative answer than that. I mean, really. Okay, 14. Another give me question here. Okay, so I got 3 raised to the 3rd raised to the -3rd. Okay, so that's going to be -3 raised to the -1, because 3 times 1/3 minus 3rd is going to be -1. Okay, so it looks like -1/3. Why does it have to be positive? It's a cube root. If it were a square thing, then it'd have to be positive. If it were a an even root, then you'd have to worry about it. But it's not. It's an odd root. Yeah, we're using positive. Oh, right. I'm using positive exponents, right? So I can't leave it like that with a negative exponent. I'm using positive exponents. Yeah. And no one believes me, but the key believes it's minus 1/3, so I must be right. At least somebody loves me. The key loves me. Whether or not, I don't know about the rest of you guys, but. All right. Now this comes right out of the physics book, obviously. And all right, so I draw myself a picture, and I've got 945 pounds. Okay, so I'm gonna drop a construction line down this way. I'm gonna say I'm at a right angle, and then I'm gonna say, you know, I got something like this. This is 58 degrees, and then I got another one over there. Same thing, 58 degrees over here. Okay, half of that weight is going to be on this side of the green line. The other half is going to be on the other side. Now, both of those are just the y components of T1 and T2. But half's going to be carried by T1, half's going to be carried by T2. What's half of 975? 43, 437.5?
487.
487? All right, 487.5. Okay, well, what do I know? I know one side. I know that's a right triangle. I want to know T1. Okay, so the tangent sine. The sine of 58 is the side opposite, 47.5, divided by the hypotenuse, T1. So that being the case, T1 is going to be 487.5 divided by sine 58. Really? Yeah, really. 57.5 divided by the sine of 58. Boom. All right, so I've got 57.4, 57.5, 575. What was the question? Equal cable support. Find the tension in each rope. All right, so what do I want to answer? T1, tension 1, 575?
Yes.
575. What's the tension in T2?
Same thing.
Tension T2, 575. Okay, how much do I take off for this answer? Minus 2 for units.
Oh.
Okay, so, and again, that would only be if you got everything right so far and you haven't missed anything, and I was just trying to help you out. Like I normally do. Huh, what? Somebody said something out there. What is going on here? All right, so I'm going to take those guys. All right. And I'm going to go LB. LB. All right, now I don't have to take anything off for units, so I can take that away. All right, good enough? Okay, so tomorrow, there's no, Monday, Wednesday? Oh, tomorrow legislative forum, Friday test.
Oh.